Hi everyone. Today we will continue our discussion about inferential statistics. So today we will start section number 4. So we are almost done with the semester. So we will start with section 4, inferential statistics or inferential 2. So we are on module 8. So let's start with chapter 4. So we'll continue our discussion about chapter 4. So that was the calculator, and this is chapter. So let's start. So this is where we stopped last time. So we did this exercise. So we stopped in here. So today's lecture actually is a continuation to what we have started already. In this chapter, we talked about the descriptive statistics as well as inferential statistics that are used for categorical variables. So we started with categorical variables, and we defined categorical variables as nominal as well as ordinal variables. So the nominal types of variables, and we said that in order to describe a nominal variable such as gender, we will need to first calculate the frequencies or the count of males and females. And then we will need to report the percentage as well as the frequencies of each of those two categories. For a nominal variable, the same thing also applies for ordinal variables, unless we are using the ordinal variable as a continuous variable. But now, so last lecture we talked about descriptive statistics for categorical variables, and we also introduced inferential statistics for categorical variables. So we talked about how we can study or use inferential statistics basically to make conclusions about a population based on a sample. So in this case, we are doing inductive reasoning. So we are building or making conclusions as well as decisions for the whole population based on a sample, a randomly selected sample. So for that, we said when we have two nominal variables and we want to see if there is a relationship between two nominal variables, then we used an inferential statistics. We called it a t-statistic. We called it chi-square. So chi-square is used for when we want to test if there is a relationship between two nominal variables. And the example that we covered last in the previous lecture was if there was a relationship between gender and being discharged home. So they were both nominal variables. And we used chi-square. We also then calculated chi-square score. We converted that into a p-value. Then we used our motto, which was if the p is low, then the null must go. And then we made our decision whether the null hypothesis is rejected or not based on the p-value. So today we will continue our discussion about inferential statistics, and also about we will talk today basically about rates and proportions. We also already talked about rates and proportions when we discussed the healthcare statistics, and we learned how to calculate them. So there are several proportions and rates or variables or statistics that we need to report. Basically, they are quality measurement, so quality indicator measurements, such as mortality rates, infection rates, complication rates, readmission rates. All of those come under rates and proportions. So rates and proportions are used interchangeably in this context. So in order to create rate or proportion, we will need to actually calculate and use in the denominator the count of subjects that meet that criteria of the attribute. For example, mortality rates among inpatients in a hospital. So the mortality rate will be those patients that were admitted or were, let's say, discharged dead in comparison to all patients that were admitted at that particular period of time. So we already learned how to calculate rates in a previous lecture, so it is straightforward. So now, if we want to describe descriptive statistics, or if we want to describe proportions, we will need to actually calculate first to create a column or a variable. We will call it a binary variable which has two values. The one value is 1. We will code one value as 1 when the attribute is existing. For example, mortality rate. If there is a mortality for that particular case or row, then we will code it as 1. If there is no mortality, means the person was discharged alive, then we will code that as 0 for the mortality variable. So it is straightforward, simple, and to the point. So now it's easier actually to create a binary variable and then calculate the average of that column in order to get the percentage or the rate or the proportion of, let's say, mortality rate. Now let's look at this example here where it's a simple example. So what is the proportion of patients who are female among those patients? So we have male, male, female, female, male. So we have 5 cases. So in this case, as you can see here, we have 5 cases. So we have, I would say, oops. So we have male, male, female, female, and then male. So now we will create a new column or a variable. I will call it a binary variable for female, or you can use male, but whatever you use here should be, if this one is correct, then you put it as 1. If it is not, if a person is female, then we'll put it as 1. If not, then we'll put it 0. So in this case, I'll just put it manually instead of having an if statement, since we have only 5. So for male, that means it is not female, 0. 0. Female, female, yes, 1. Yes, 1. And then 0. So now you got the idea. Now we have, when it is female, we put 1 for the female variable, and when it is not, then we put 0. Now there are 2 ways actually to calculate the average, so you can use the average as a function from here, or you can just use the, if you might have actually end up having so many cases, so in our case we will use actually the pivot table, which will make life much easier. So I will drag female and convert it into average. So in this case I have 40%. So what is the percentage of females? Is actually 40%. So very straightforward, very simple, and to the point. So this is exactly what we had here. Now let's continue and see and look at how we can report actually how we can report inferential statistics. So for inferential statistics, as you can see here, we will have, first for proportions, we will need to determine if a sample proportion or a sample proportion or a population proportion is higher or lower than standard. Basically, we want to see if there is a significant difference between the proportion of a sample and the proportion of a standard. For example, in our case, we will give an example later, but let's say that the KU hospital is well funded. It is it has a lot of good reputation, and they have been going through the lean uh, process improvement culture or way of getting rid of waste and improving processes. So the expectation is that the mortality rate at KU Hospital, because also they have great staff, top-notch physicians, and so on. So the expectation is that KU Hospital will have fewer mortality rate or less mortality rate than the national standard of mortality rate. So the national standard basically is statistics or proportions or rates of mortality are actually reported in the HCUP website. And for KU Hospital, we can calculate that using a sample that they might give us. So, or any other hospital, we can calculate that if we have the data set in an Excel format. So the inferential statistics for proportions are used to determine if the sample proportion or population proportion is different from a standard proportion. And another concept that we need to keep in mind is when we look at inferential statistics, we need to keep in mind whether the hypothesis or the alternative hypothesis is one-sided or two-sided, means one-tailed or two-tailed. So what we mean here by two-sided hypotheses. Let's say that, let's go back to the example that I gave where we said the KU hospital might have a different proportion than the national proportion for mortality rate, right? So there are two ways that I can state these hypotheses. So I can say there is a significant difference between KU hospital and the national average of mortality rate. So when I say there is a significant difference, I am not saying whether that difference is going to be great or higher or lower. I didn't mention in this statement that I just mentioned whether the KU mortality hospital, KU hospital mortality rate is going to be higher or lower. So if I say the mortality rate for KU hospital is significantly different from the national standard mortality rate. Now I'm not taking sides. So in this case, it is going to be two-sided hypotheses. So two-sided alternative hypotheses. However, if I want to make it one-sided alternative hypothesis, then I'm going to state it. There is a significant, or there is a larger, or I would say the mortality rate at KU hospital is lower than the mortality rate of the national average. So in this case, it's going to be represented with this last one here. So the alternative hypothesis is going to be the mortality rate or mortality proportion at KU hospital, which is the sample, is less than the mortality rate of a national standard, or the national mortality rate, which is the standard. That's how I would state it if it is one-sided. Another way to state one-sided is to mention whether if it is larger or lower. So in the first point that I said, the mortality rate at KU hospital is lower than the standard, I can also state this hypothesis in a different way. I can say if I am expecting the mortality rate at KU hospital to be larger than the national standard, then I will use this top one. And as you can see here, the alternative hypothesis is the opposite of, the null hypothesis is the opposite of the alternative hypothesis. One thing that you can notice here is that the null hypotheses they always have the equal sign in them. And the alternative hypotheses, they don't have an equal sign. They have non-equal. So now we have understood the difference between one-sided versus two-sided alternative hypotheses. Now let's continue to look at if we want to find the difference, whether there is a significant difference between the sample proportion or rate and the national standard or national proportion rate. So going back to our example for mortality rate, in that case, if we want to see if there is, for one sample, let's say that we were given only one sample data set for KU hospital or any other hospital, and we wanted to calculate the proportion in that sample that was given to us, and we want to compare it to another standard, which is this national standard, or let's say the company has a standard, or the hospital has a standard, or a goal that they want us to test or to analyze against, then we will use one sample z-test proportions test. So let's look at an example kind of to put everything into perspective. So in this example, it is telling us that there is a company that has an abidance or a compliance rate. Their goal for compliance rate in terms of flu vaccination rate to be 85%. That's their goal, all right, or benchmark or standard that they want to always meet. They want to have 85% of their employees complying with the flu vaccination. So they hired you as an analyst and they wanted you to collect a sample from 10 employees and ask them whether they were vaccinated or not. And then they want you to study whether there is a significant difference between the proportion from the sample of 10 employees you collected and the standard, compare it to the standard of 85%, which was the goal of the company. So they want you, and they are willing to accept 5% chance of making incorrect conclusion. So now, since they said they want you to see if there is a significant difference in the sample proportion and the standard proportion, did they mention whether that difference, the sample is going to be larger or lower than the standard? They didn't mention. Then we need to keep that in mind. That is going to be two-sample or two-sided alternative hypothesis. Now, we will need to go through the 5 basic steps in hypothesis testing that we covered in a previous lecture. So the first step of hypothesis testing is to determine the null and alternative hypotheses. So the null hypothesis, in our case here, it says that the sample proportion or the sample rate is going to be equal to the standard rate. So whatever the sample rate that we are going to calculate is equal to the sample or to the actually standard rate, which is 85%. So that's our null hypothesis, which says that there is no significant difference between the sample and the standard rate, if we read it in a different way. The alternative hypothesis, on the other hand, says that the sample proportion is not equal to the standard proportion. It means they are different. There is a significant difference between the sample and the sample proportion and the standard proportion. So those are the hypotheses. They are set up for us. Now, the second step is to set the alpha level. In our case, we said it is a rule of thumb to use the alpha level of 0.05. So we already have that. The third step is to select the appropriate test statistic that is appropriate for this particular scenario. In our case here, as you can see, that we have only one sample, and we want to compare this one sample's proportion to a standard. In this case, we are going to use the one sample z-test for proportion. That's the appropriate test for this particular scenario. The second or the fourth step, as you can see here, we will need to calculate the z-score using this function that was given to us, and we need to compare it to a critical value, or we need to convert this z-value or z-score into a p-value. That way we can make a decision based on the p-value that will be calculated for us. Based on that, we will be able to make conclusions whether to reject or not reject the null hypothesis. So now, let's look at this example. that we were just given here. In this example, so we interviewed, or you as an analyst, you interviewed 10 employees, and you asked them an yes or no answer whether they were vaccinated or not, and you call this variable vaccinated. So the existence of vaccination, if they said yes, they were vaccinated, we'll put it 1. If they said no, we'll put it as 0. So it showed that when you collected the data, you found out that patient, or the employee C, employee G, and employee I reported that they didn't do, or they didn't take the flu vaccination. So in this case, we will put it 0. So for me, just to make it easy to write it, I'll put all 1, and then I'll put 0 for those ones who said they did not vaccinate. Now I calculated this. It is calculated. Now I need to know what is the percentage, what is the proportion or the rate of those who were vaccinated. So to do that, I will just use pivot table, and then I'll select this guy, and then I will calculate the average, where it says average, right? So the average is 0.7, means 70%. So 70% is the average. So now I calculated that, and now I will actually go and use, I will go to the module, and I already created for you a calculator for that function to calculate the z-score for one sample z-score. So the calculator is here for you, one sample z-test calculator. All it wants you to do is actually to fill out those guys and fill out these hypotheses. So for us, let's do this. I'll just copy this content, and I always like to go methodological. So I want first to come up, or to write, or to state the null hypothesis and the alternative hypothesis. So the null hypothesis says there is no significant difference between sample proportion or / rate of vaccination and the standard proportion / rate, right? So that's another way you can state this is by hypothesis 0. You can say that the sample proportion, it says, equals the standard proportion, which was 0.85. The alternative hypothesis, on the other hand, it says that there is a significant difference between, so I'll copy and paste it, because this will help me after I decide whether to reject the null or not reject the null. After I set this one, then I will be able. So alternative hypothesis will be B does not equal. So I will use this sign to represent whether it is equal or not. So it says here the sample proportion is not equal to 0.85. So now set alpha level. I will use this one, and since it is two-tailed, it is two-tailed. You can use either 0.05. I'll just use 0.05 for now. Now I will calculate the z-test statistic. So I need to calculate the z-test statistics using the calculator that I just explained to you, that we were able to pull out from module 8. So the calculator here, so we calculated, in our case earlier we calculated the proportion for vaccination. We say the proportion from the sample was 0.0 or 0.7. So the sample proportion is 0.7. I'll put it here. The standard proportion is 0.85. Now the sample. How do I calculate how many did I have in my sample? So how many did I have in my sample? Let's say I have so many and I don't want to make any mistakes. I will just go through pivot table, and then I will drag the vaccination, and then I will select here as count. So the count means how many, it tells me the sample size that I just collected data from. Now I have 10 as sample size. Now this is my Z-score or Z-test outcome, negative 1.33, right? So I'll take this one, I'll put it here. So my Z-score, I'll put it here, negative 1.33. That's my Z-score. Now I want to see what is it equivalent to. So the p-value, I need also to calculate the p-value, because the p-value will help me to see whether I need to reject or not reject the null hypothesis. So to calculate the p-value, I provided you with a calculator here. It's an online calculator that you will need to use. So the z-score, what was the z-score that we calculated? It is negative 0.33. So I'll put this guy here, negative 1.33. So what was the significance level that we said we want to use? Alpha level, significance level, 0.05. That's the one. Was it one-tailed or two-tailed? We said it is two-tailed because we didn't mention whether our sample is going to be larger or smaller than the standard. So it is two-tailed. Now calculate this guy, and this is what we got as p-value. Now we'll put this guy, our p-value here. Now you can see, we'll compare this. We will use our motto. If the p-value is low, if the p is low, the null must go. In our case, the p is not low, so the null must not go. So in our case, what we will say is the p-value must not go. So the null hypothesis must not go, because the p-value is, since the p-value is not low, the null must not go. So in our case, I would say here, my conclusion is there is no significant difference between the sample proportion rate of vaccination and the standard proportion rate of vaccination. So this is my answer and conclusion. Very straightforward. I just copied and pasted from my null based on the p-value. Straightforward, right? So now let's do this exercise together. There is an exercise here for us. Let's do this exercise together. So in the first question here, it's asking us to use the CHD dataset that we have in Module 8, and they want us to calculate the routine discharge rate for the sample. So discharge rate for the sample of patients discharged with this particular DRG. So now let's go to Module 8 and get the CHF dataset. So they want us to calculate the discharge rate that for routine discharge rate. So we have so many discharge here, so many discharge types. They want us to use or to calculate the discharge rate for routine discharge only. So for that, because we don't know yet what it is unless we have a data dictionary here, so since we don't have it here, let's go to the data dictionary documentation that was given to us in this website. So data documentation link. So what I will do here, I'll just go discharge destination, Control F, and then I will look it up. So which one of those codes represents this routine discharge? Here we go. We found it. So it is the 01, which is basically discharge home. It is, they call it routine discharge. Okay. So now we know the code. Can go back to Excel. Now I will need to create a new variable. So I'll call it this routine discharge. So I'll just call it, give it this name, enough. And now I will create the variables or the values for it. So if the discharge destination equals, so remember this column or the values here are used as text, as you can see in the top corner. That shows that they are used as text. So I will put quotation marks 01. So if that cell equals 01, close that quotation. If the value is true, then I'll put it as 1. If not, then I'll put it as 0. So basically I'm creating a binary variable for routine discharge. So it is done for me, right? On the other hand, the question here is also telling me only DRG for 293. So there are two ways you can do that. You can either sort this column from Z to, one option is to sort, because they want us only to calculate the DRGs that are 293. So one way is actually to collect or to select only those 290 by sorting them first and selecting those 293 values and put them in a new Excel sheet. Oops, what did I do? Okay. So now I just selected those. So those are just the, how many do I have? I have 81, right? So now I have DRGs that are for 293, because that's what the question is asking me to do. Calculate the discharge, routine discharge rate for 293. Now I should be good. To do that, I can just do like what I did earlier, create a pivot table and drag the routine and put it as average. So the average here is 0.0 or 0.358. That's the average. Now I also need to be able to calculate the sample size. So the sample size should be count. So I'll put it here. So this is my sample size and this is my percentage or discharge, routine discharge rate is 35.8. All right, for this sample. Now what else do they want me to do? So I got this one done. So I answered the first question. Now the second question is asking me to determine, so I calculated the sample routine discharge rate. Now they want me to identify the standard discharge rate for the national discharge, the national standard discharge routine discharge rate for Medicare for particular year, that is 2013, from the HCUP website. So for that, I will need to go to the HCUP website, and you will need to take notes on how I will navigate through this website. Otherwise, you might struggle to find it again. So make sure to take notes. So national statistics on all states, so I will select this one. And then I will select the second option where it says researcher, medical professional. And then I will select the first option where it says statistics on specific diagnosis or procedures. And then in the question here, it is asking me actually to look for 2013 for Medicare patients, right? So 2013 and DRG. So they told me they want me to collect data for 293 DRG. So it should be diagnosis related groups, DRGs. Now all discharges. I want all discharges, no restrictions. So what was the name, what was the code for DRG that they want me to collect? It was 293. So 293, I will search for it. I'll put it here in the search, 293 and search. Here we go. We got it. Heart failure in shock. Now, next. Now it is asking me actually in this question here to identify or to determine the routine discharge rate for that particular DRG for Medicare patients. All right. So for this case, I will need to get the rate of discharges, and I will need to select here discharge status. In your assignment, you are asked actually to find out the mortality rate. So for the mortality rate, you will need to select this option. So remember this, take note of it. Mortality rate from the HCAP, you can find it here. So I don't want to repeat it. So next. Now we will need to select the payer because we want the Medicare. So Medicare is one of the payers. So I'll select payer and then move on. Then I will accept. Now there are two tables here you will notice. The first table, that's the table that we will always be using. The second one reports here the standard errors. We don't actually have nothing to do with the standard errors at this stage. For us, we want the actual rates. We don't want the standard error rates because it's not relevant for us here. So the national, now looking at this table, we can identify the Medicare and routine discharge rate, which is 56.44. So now, can we solve this problem? So we answered the first question, we answered the second question. Now let's answer the third question. So now it is asking us to test the hypothesis that the routine discharge rate for the hospital, which is the sample that generated the sample data, is different from the US rate, which is the standard. Okay, so they said test whether they are different or not. Did they say test if the sample is greater than the standard? Or did they say test the hypothesis whether the routine discharge rate for the sample is lower than the standard rate? No. So they said they didn't mention, they didn't identify whether to test whether the routine discharge for the sample is higher or lower. They just said different. So in this case, it is two-sided. So it's very important. Now they want us to show the 5 hypothesis steps. So let's do that. We'll use the calculator again. So I will just copy everything that we have here, like similar to the same way that we did earlier. I will open a new Word document. And then I will answer all those questions here. Null hypothesis. So the null hypothesis says there is no significant difference between routine discharge rate for the sample and routine discharge rate for the standard, which is the national standard, right? So that's the first hypothesis. We can put it also in symbols. I can say hypothesis 1, the sample proportion is equal to the national proportion. So what was the national proportion that we found here? Here it is. So the national proportion, so make sure to use it as decimal. So 0.5844, that's the national. So make sure to use it as decimal. So 0.56.44, that's our null hypothesis. So now I will create the alternative hypothesis. So the alternative hypothesis will be P is not or the sample proportion is not equal to 0.5644. Now I was able to go through the first step. Now the second step, as we mentioned, we will use 0.05 as our rule of thumb, and then calculate the z-score. Now we will need to calculate the z-score. So let's calculate the z-score using the calculator that was given to us. So what was the proportion for the sample? So the proportion for the sample was given to us here and here. So the proportion for the sample was given to us here. So it is, I'm going to use the Excel sheet, the calculator, put it here, that way I can see both. So the sample proportion is 0.358. The standard proportion, which is the national standard, I will need to take it or to find it here. Or we already put it actually in our hypotheses here. So it is this number. So make sure to use 0.5644. Don't put 56.44. So because we are looking at the fractions or the proportion. So I'll put this one here. So I'll put it here. That's what I have. And now what is my sample size? The sample size, you remember, we already calculated it using the count, which says it is 81. Now, automatically, I was able to find the z-score, which is negative 3.75. So now looking at this here, to fill out this form, what is my z-score? I'll just put it here, negative 3.75. So that's my z-score. Now I need also to be able to report the p-value. So the p-value, I need to calculate it using that online calculator. Remember the online calculator that was given to us here, p-value from ZScore Calculator. So what was my z-score that I calculated? It was negative 3.75. So negative 3.075. Here it is. So significance level, it is 0.05. One-tailed or two-tailed? It is two-tailed. Calculate. Boom. You can see here our p-value is done. It's calculated for us. So in this case, I will just put the p-value here. When it is blue, that tells me it is low. So since the p is low, what I would say, since the p is low, the null must go, right? I'll just put it here. Now, the null must go. So if the null is gone, then we will have actually the alternative hypothesis. So if the null is gone, so if the p is low, the null must go, then we will definitely end up with the alternative hypothesis because the null is already rejected. So this is our conclusion. There is a significant difference between routine discharge rate for the sample and routine discharge rate for the standard, which is the national routine discharge rate. So now we can actually make this conclusion. This is straightforward, and I hope that you can replicate this exercise, those two exercises. This will help you a lot when you are working on your assignment, and also for the quiz and for the exam. And good luck to you all. Bye.